Um, so in our work on structural code editing with multiple cursors, we consider the fact that developers frequently make many refactors to their code bases as they're working. Some of these are quite standard refactors, which have good support in almost every code editor. That's things like renaming a variable, extracting certain lines into a function, or deduplicating constants. But developers also often make refactorings that are quite specific to their application. And for these, they can't use a standard built-in refactoring and have to resort to a different set of tools. And while there is a wide variety of tools for these purposes, we find that they either have limited expressiveness or limited interactiveness. So let's consider an example of refactoring as we go through it. On the left, we have an initial piece of code. This is JavaScript code. And the core of this is object literal, so a dictionary containing some functions which are meant to be some sort of event handlers. And after the definition of this literal, there's a loop which wraps every function at runtime in a higher order warn on error function. Now consider the situation where the developer wants to add an event handler which is not wrapped with warn on error. What they might now do is directly in the code add the wrapper function to every existing item so that they can add a new entry which is wrapped differently. Here with ignore error. So this is like a pretty realistic small change, but also a little bit repetitive. And one interesting thing about this change is it's completely not standard. You'll never find a standard ID refactor for take every property in this object literal and wrap it in a specific function call. So here's kind of a chart of different tools that you might use to avoid manually changing every location here. So I've organized them split in kind of two dimensions. First, there's the separation between textual and structural tools. So textual tools here are the ones that work with lines and characters and words. And the structural tools work with the syntax tree of a program and manipulate different nodes and create new ones. On top, there's this other axis of interactivity. And this one I'll explain a bit more as we go through. So considering this specific edit, let's take a look at how you might use a regular expression to slightly automate this repetitive change. Now, this is actually a case where textual tools might struggle with this sort of edit. And you can see this pretty clearly from the regular expression that we've had to use here to make this edit possible. So what it's doing is it's capturing the left-hand side, the key of the property, and the right-hand side, the value of the property. But at the end of this regular expression, you see this look ahead where it's actually matching exactly 4 spaces followed by a quote or a closing curly brace. And the reason this is necessary is the regular expression is actually extracting information about the structure of the program from the indentation and the formatting that's been encoded into the text. So this is really a very hacky way to reconstruct the structure, but it's necessary because in this case we have some properties which span multiple lines. There's no nice delimiter around property values like a parenthesis or something. And properties are separated by commas, but they also contain commas internally. So it's very hard in general with a textual tool to isolate exactly the right structure. And fundamentally, we've found a refactoring task where the operation we want to do is structural in nature, so we'll always have difficulty performing it with textual tools. We see a similar problem in another common textual tool for repetitive edits, which is a multi-cursor text editor. So actually these days, almost every code editor supports multiple cursors. Typically the workflow is you would click in somewhere in your code and get an extra copy of the same main cursor that you have. And for this edit, we would click in every single location before the properties and can type out our new wrapping warn on error function. But notice how we've actually manually had to define every single location. The tool hasn't actually solved the problem of reconstructing the structure from the text. We've just manually had to point it out in every location. And we have exactly the same problem when we want to write this closing parenthesis, because we have to find the end of this inner expression. And again, that's not really possible by going to the end of a line or going up to the next comma. We just have to manually declare every single end of that expression. So this textual tool is also having the same issues reconstructing the program structure. And there's also this interactivity axis that I've mentioned before. So a regular expression is something I would say is not very interactive. You have to step out of your normal code editing, character by character workflow, and you have to start writing an expression that will match the different objects you're trying to edit. And through trial and error, construct an expression. You might not see the results immediately. The edits definitely don't happen immediately until your expression is nice and fully working. But in between, you have a very different workflow from just normal single location editing. Now, one advantage of multi-cursor as a concept, both in text and structural editing, is that it gives you more interactiveness. So the way you would edit a single location, just normally clicking in, typing, deleting, selecting whole words, jumping to ends of lines, all of that still applies when you're working with multiple locations. You're not stepping out into a different editing paradigm to automate your repetitive edits. So that's what we're going for when we mean high interactiveness. Now let's consider a structural tool and how it solves some of the problems that textual tools have in this situation. So the code snippet you see here is a JS CodeShift script. That's the de facto standard library for performing AST-based refactorings for JavaScript code. Sometimes it's used when an upstream library with lots of consumers makes some breaking API change, and they want to allow all the library consumers to automatically adjust to the new interfaces. So they would write a script like this and apply it to lots and lots of files. But the overhead of writing such a script is too much that anyone would realistically do this to change like 10 locations in the code. Also, this kind of setup has very low interactiveness. Until your script is fully working, you can't really, it's difficult to try it out. It's difficult to see intermediate steps here. And it's also difficult to see at a glance how this maps to the code that you're working with. So if you were in an editor working with and looking at a piece of code, you're suddenly pulled out of that and have to work in a completely different context. So as I demonstrated in this example, there are some refactors that can't be done with standard tools because they're just too application specific. They are not so reliable or not so practical with textual tools because there's not enough textual cues and the problem is structural in nature. And a tool that we have for performing these very reliably, these AST-based refactoring scripts, they take a developer out of their normal workflow and aren't the same as normal single location interactive edits. So what we wanted to do with Forest is bridge the gap between the interactivity that multi-cursor text editing gives and add in some of the reliability that users of AST-based refactoring scripts have. Of course, when you write such a refactoring script, you're sitting down and taking the time to carefully write down all the steps so you can perform more advanced, more complex refactorings than you could interactively. But we want to capture at least some of that ability in an interactive environment. So Forest is a hybrid structural editor with TypeScript. That means it's not fully pure, only structure, no text. We actually show the code to the user as normal text, which helps a lot with readability and keeping an overview of the code. And we let new code be inserted just as normal text as well. However, all the navigation and all the editing that the user performs is done with structural commands. For example, when they delete something, they delete a node in the AST, and the result is newly pretty printed, adjusted code. And in general, Forest has a continuous pretty printing setup, so every single edit always results in fully pretty printed code. But the key thing about Forest compared to previous structural editors is with built-in native multi-cursor support. And one reason this is interesting is structural editors have been looked at quite a lot, especially like 20, 30 years ago, and eventually people stopped looking into them because they were quite impractical. You couldn't really use them in real life. And multi-cursor text editing hasn't actually been around for that long. So multi-cursor was most likely first introduced with Sublime Text, which was less than 10 years ago. And since then, it's been added to almost every code editor we use. But these two things haven't been looked at much together. And we believe that multi-cursor environments highlight some of the advantages of structural code editing to offset a bit of those costs and pain points. So let's look specifically at this edit again and how it looks in Forest. On the left, you see the actual editor area itself, and it looks quite a lot just like a plain text editor. On the right, you see kind of a demo explanation area where it explains the steps that we're going through. So then to perform our edit, we move here inside this object list row. Unfortunately, it's quite hard to see on this slide, but we have 6 cursors now. So what Forest has done is we had a selection of 6 AST nodes in one cursor, and it's just split on the AST node boundaries. And as you saw before with the textual tools, this was something that was quite difficult to do. You had to put in a lot of work, you had to use workarounds to get this split, but a natively structural tool can get it easily. And now that we have 6 separate cursors, the concept is the same as in multi-cursor text editing. So in general, every operation will be replayed at the same time on every cursor. Here we're moving to the right sibling, although in a text editor this would also be quite straightforward. And then we're wrapping the property by copying the values, inserting a new call, and pasting the values inside. Also notice the continuous pretty printing where everything is always adjusted. Forest is designed in such a way that all the navigation commands are structural, which means that even if pretty printing happens right before you issue a new command, the meaning of your command won't change because the commands are not defined on the printed text level. In this example, actually, all the edits after the splitting are quite straightforward. So the benefit of the structural editing here was just in the split step. But there are other edits where the editing steps themselves benefit from structural editing. For example, moving between child nodes in an AST where the boundaries aren't very clear, or again, handling these multi-line, single-line cases in a consistent kind of way. What's also important here is this interactivity aspect. So now we've edited with 6 different cursors, but the following parts of the edit, we actually want to add this new property with the ignore error wrapper, and we want to remove the for loop. So the way we're going to do that in Forest is remove all cursors except the first. This is quite a standard multi-cursor operation. And then continue editing like normal to get our single location changes done. So there's no difference between editing a single location or a multiple location. You're in the same editor, you're using the same commands, but we can choose to edit multiple locations or single locations in the same interface. So in general, Forest has quite a wide variety of features that by themselves aren't so interesting, but they all combine into a consistent experience. There's the single cursor aspect, where there's lots of kind of common trade-offs that different structural editors make. And in our paper, you can also read about how we've chosen to make some of these trade-offs differently to other structural editors. And there's also features which are designed specifically for multi-cursor text editing. A couple of these actually apply to multi-cursor editing, and a couple actually apply to multi-cursor text editors, not just structural editors. So today I want to highlight 2 of these.
our hierarchy of cursors concept, and how we do filtering with cursors to approximate conditionals that you might have in a refactoring script. So this is a very, very simple program, but it's designed specifically to show how the hierarchy of cursors works. We have two almost identical functions, each with 3 parameters, and this is TypeScript code, but without any type annotations at the moment. So what we'd like to do is go through and annotate all of the arguments of this first function with a type, just number in our case. So the way we'll do this in Forest is we'll first move to the parameter list, and again, same as in the earlier example, split to get 3 cursors. Then we'll append some text to add our type annotation. So that was straightforward, but the edit we'd now like to make is to add a return type annotation to the whole function. So the area we need to add that annotation is immediately after the parameter list, just before the body of the function. And we need to add a single number annotation, not 3. But since we currently have 3 cursors, we need to reduce to 1 cursor to be able to make that edit. Again, as typical multi-cursor operation. So we reduce to 1 cursor, here arbitrarily the first cursor, and we move to the back of this parameter list to add our annotation. So now we've done this edit for one function, right? But in a multi-cursor text editor or multi-cursor structural editor, the goal is to be able to perform an edit in multiple locations at once. So what if we wanted to do the same thing, but for both functions at the same time? Well, the natural way to do it would be to select both functions and split a cursor so that we have 2 cursors for 1 per function. And then ideally, we'd want to be able to perform the same edit we just performed on one function and have it work correctly in this kind of nested context of another multi-cursor edit. So again, move to the parameter list, split to have more cursors. Now we have 6, not 3. Add our parameter annotation. And now the step we previously did was reduce to first cursor. And in every multi-cursor text editor that exists, what this would do is leave us with just the 1 cursor in the upper left there. And that's a problem because after we perform that step, we would be adding the return type annotation only to the first function. So this like key core operation of removing all cursors except like a specific main cursor stops us from nesting different multi-cursor edits and composing them. And that's why in Forest, the behavior of this is quite different. Instead of reducing to the actual first cursor when you perform that operation, in this case, it's left 2 cursors, 1 per function. And you'll see why it's specifically these 2 in a second. But what this lets us do is perform the rest of the edit exactly as before. Select the whole parameter list, but now with 2 cursors, not just 1 like in every other multi-cursor editor, and append our return type annotation. So these edits like nicely composed so we could perform the same multi-cursor edit, but again, itself in multiple locations. And the way Forest determines which cursors are left from these operations is with something we call the hierarchy of cursors. So this hierarchy is not based on the syntax tree, it's not based on the relation of the nodes there. It's actually based on the creation relationships between the different cursors. So originally we had 1 cursor for the whole program. That's this root node of the tree. Then we split that cursor twice to have 1 cursor per function. That's the 2 intermediate nodes of the tree there at that first level. And then each of these cursors was split to have 3 cursors for each item in the parameter list. So 6 in total. That's the cursors 1, 2, 3, and 5, 6, 7. And then when we performed the reduce to first cursor operation, Forest didn't reduce to the first cursor in the program code in general, but performed that operation once per each group of nodes in the hierarchy of cursors. So for each of these bottom level nodes, it reduced to the first one based on their parents. That left us with the cursors marked 1 or 5, which edited the locations 4 and 8 respectively. So this hierarchy of cursors is actually something that could be applied to multi-cursor text editors and would give the same benefits there. namely letting us compose multi-cursor text edits in a reliable, predictable way. Okay, so on to the second edit I want to demo. Here we're trying to perform, we're taking this object assign function, which is like a standard built-in function, and we'd like to replace it with a newer syntax that's available in newer JavaScript. So this newer syntax can replace some of these object assign calls, but not all of them. There's some restrictions for stuff that can't be converted. So say we originally start with 1 cursor per object assign call, which is the case here with our 6 cursors. Before we perform the actual edit, we need to conditionally stop the edit being performed in some places. And there's 2 kinds of conditionals that we're actually going to use here in Forest. So first, we'd like to not transform calls, or to only transform calls where the first argument of the function is a object literal. And that's not the case for that first marked object assign call here. So the way we do this in Forest is we navigate to that relevant location, and then we perform a normal editing operation that we expect to actually fail in some cases. So Forest has the idea of failing or succeeding operations in general. And an example of a failing operation would be if you're on a leaf node in the AST and you say go to first child of that leaf node, well, it has no first child, so the operation fails. And Forest has different modes for handling failure, which let you achieve different results using the failure mechanism. So the default mode is just to ignore the failure and have each cursor kind of independently work. If one fails, it just stays where it is, and the other one performs the operation. That's the typical design of most multi-cursor text editors. But what we're going to do here is use the strict mode. So the operation we're going to perform is actually checking if the current selected AST node is an object literal. That's performed using the structural search feature of Forest, which I'm not actually going to show on this slide. But once the structural search completes, the cursors with object literals succeed, marked in green, and the cursor marked in red fails because it's not pointing to an object literal. This is what happens in the strict mode. In the kind of default relaxed ignoring mode, that cursor on A would just do nothing specific, while the others would move to the object literal. So now, in this case, we want to exclude the failing cursor. And we can do that by just confirming that we want only the successful cursors. Now, the other condition is the opposite of this. So what we want to do is not convert object assign calls, which contain a spread, like a parameter spread, which is this triple dot syntax over there. And that's the one with the B. So the concept is the same. We perform a failing operation, but now it's mirrored. We want to actually keep the failing cursors and drop the successful cursors. And now we have the specific cursors we want to keep and can perform all the other editing steps, which admittedly are sort of complicated and don't give a perfect result in the end. But we've only applied them to the locations we wanted to and have got a basic form of conditional operations. And conditional operations in general are something that multi-cursor editing can do a bit more naturally than a macro in editors can, because it's seeing all the cursors and all the locations at the same time. But with this basic form of conditional, that's what we started out with as we went into our evaluation. And that's enough to cover actually a good amount of cases. Also, about the structural search concept in Forest. Forest has a structural search, but we intentionally didn't make it very complicated. There's not very many features for matching a structure nested deep in another structure with arbitrary levels in between, because some of this can be achieved by performing normal multi-cursor movements, then searching a bit, dropping a few cursors, searching a bit more, doing a few more normal operations. So we went for a simpler structural search system, but chose to integrate it more closely with the other commands in the editor. So one of the goals was to try to reproduce the simpler edits that are done with AST-based refactoring scripts just as reliably, but with more interactivity with our multi-cursor structural concept. We collected 48 JS CodeShift scripts on GitHub, and we attempted to perform the same edits that those scripts were performing in Forest. In 11 of the 48 cases, we managed to perform the edit with no limitations or with quite minor limitations. And in 17 of the cases, we identified some kind of feature or limitation or bug where we believe if that's fixed, and it's relatively straightforward to fix, that these cases would become possible to perform as well. However, in 20 of the cases, we consider the edit to not be possible in Forest. And for the reasons for that, we'll get to on the next slide. So one of the things you'll find in our paper is a listing of all the examples that we tested and a discussion of certain issues that we encountered. So in this table, you have some of the top issues grouped into categories. And for every script that we tested, we counted it multiple times here, once for every issue we encountered with that script. Yeah, I won't go into much detail here. The different issues are a bit nuanced, and you'll have to take a look in the paper to see more about those. But in general, we group them into these broader categories of missing features first that require some kind of conceptual change. For example, to our filtering system, it just has conceptual limitations, and you need to design around that. For some of these, we have ideas. For others, we don't. It's not really clear how to solve those problems. We also have missing features that are actually very straightforward to introduce into the current model if that just needs to be done. But that would also open up possibilities for some of these currently not possible edits. And we also had a category, a major limitation of trying to perform the same edits as these refactoring scripts in an interactive way is that sometimes the refactoring scripts can do very complicated things. They can be long, they can have large tables of to look up certain keywords, reserved words in. They can even do things like taking strings and parsing them in order to create AST nodes based on that parse of the string, which obviously you're not going to be able to do interactively with some keystrokes in an editor. So about half of the edits which we think couldn't be performed in Forest can't be performed for that reason. You'll always be more limited in what you can do interactively than in a written down, carefully considered script. In summary, we combined multi-cursor editing with structural editing. Structural text editor is a mistake. It's just a structural editor. And we implemented that for TypeScript, which is actually a relatively complicated syntactically language. We wanted to use it to perform application-specific refactorings, so the kind where you don't have a built-in refactoring in your editor, and to do that interactively. The same workflow for editing, single and multiple locations, no jumping out of context to a different concept. And we think we achieved some of the expressiveness that refactoring scripts give a developer while maintaining some of this interactivity. On that website, you can find the live versions of the demos I showed screenshots of here. You can go through them step by step, and you can try freeform editing for yourselves. And below, you have a link to our paper. Thank you.
Time for a question or two. Do we have a roving mic?
Yeah.
Ah, the one you're using?
Yeah.
Okay, good. Yes. I'll maybe invite the next speaker just to get set up while we're taking questions.
Yeah, I don't have a question, but very interesting work. We at Amazon have been exploring something similar in a different, slightly different domain. So we're looking at interactive ways of synthesizing static rules. And the problem there is, again, of specifying the code context. And we are looking at multi-cursors for doing that. So maybe we can talk offline. This looks very interesting.
Sure. Thank you.
Time for both? Okay. Just a quick one. Great work, really exciting. Obviously, you can see a lot of cultural lineage from Vim here. And I'm curious if you have some reflections on sort of Vim uses an iteration model versus the all edit model. I use multi-cursors all the time now, but I'm frequently surprised by the result if you do a large refactoring or if you have more than a page of code. Then you go, oh, geez, I didn't realize I'd selected that other thing that was close. Have you explored that much? Do you have thoughts about the usability or like a comparison between those approaches?
Okay, so just to clarify, you mean you're surprised when you use multi-cursor editing that you accidentally selected some...
Yeah, and
Yep, okay.
you know, when you have a regex search or something, obviously that's a lower fidelity than what you're doing, which is
Yeah.
why I was curious. But the Vim benefit is that you explicitly see each instance of the little microscript.
I have 2 things to say about that.
Awesome.
So first of all, there's one of the editors that was a strong inspiration for this is Cocoon. I hope I'm pronouncing it right, but maybe not. That's actually a Vim-inspired editor, but from the ground up multi-cursor. So that kind of inverts Vim's commands to start with a kind of visual mode selection first, and that has some very advanced features. It's basically the most advanced multi-cursor editor for text, with lots of like splitting operations, regexes, rotating content of cursors. And I think that that's actually the best thing to look at to see like, how does multi-cursor compare to the macro concept, ignoring text versus structural, because it's really close to Vim, with the only difference being they're using multi-cursor instead of typically macros. I think there's a few areas where multi-cursor is more natural than macros. For example, when you're recording a macro, you usually have to imagine what it will do in different locations. Imagine what kind of stuff we encounter. So if you're like recording 10 steps of commands, you have to imagine what each one will do. Where if you're doing these 10 commands in multi-cursor, you might get to like the 5th command and see, oh, actually, no, that's breaking half of these locations. I'll undo that one command and go from there.
Yeah, that's really compelling. The undo obviously wasn't in the demos because you showed us successful things.
Yeah.
Be interesting to see that kind of live interaction.
And the other thing that is a bit different in a multi-cursor setting is if you have any kind of assumptions that the editor makes. For example, in Forest, if you're moving between sibling nodes and you reach the end of a list, it assumes you might want to move to the sibling on the next higher level of the tree, and it moves you up there, which is quite natural in a single cursor. But if you're editing lists of different lengths, that might be unexpected because it might happen at the wrong time. And in multiple cursor, the editor is seeing all the locations at once, so it can do things like delay that automatic command until all cursors can perform it, or it can prompt you whether you want to perform this command. So that's to multi-cursor. To the overview aspect, I think that's solvable by letting you easily cycle through the locations you're about to edit. Because in the end, if you say the advantage of macros is that you see every location, well, you can also see every multi-cursor location in principle. But I think what's also interesting is because you haven't, something I'd like to explore in the future is when you know all the different cursors which are selected, you could group them by what kind of syntax they're currently selecting and show you groups of slightly different kinds of code that you're going to edit to avoid mistakes.
So if this question, so if this question was short, then my question will be super short. I hope. I hope it will not be considered to be too weird. Do you think that your concept would also be useful for natural programming, natural language, for instance, for editors used by playwrights? And I don't mean that they use a powerful markup language, because a LaTeX source code looks a lot more like a program than a flat text.
That's a perfect question. I'm sorry. I actually made a prototype once for a German editor where you could edit sentences actually as a graph, not as a tree. And it would do things like automatically adjust the endings of every single word when you change like the gender of a noun. So it is possible. I think no one will ever use it, but it's fun.
Let's thank Philip again.